Okay, so this is a walkthrough, a very simplistic walkthrough for honors chemistry of the quantum mechanical model and the shapes of orbitals and how many electrons they hold, and sort of how we can write electron configurations based on the addresses or the general probability locations of electrons. So we're not going to go into what L and M sub L and M sub S stand for, but think of these as levels as far as your address goes. So for example, N could be like the state you live in, and L could be the city, and M could be the street, and then the house number, M sub S might be the house number. And so every electron has an address, just like you have an address. All right, so I saw this done before, and I think this helps a lot as far as understanding how electrons are arranged. Okay, so if you think of every element every element has its own apartment complex. But the apartment complex is set up in a particular way. And if you think of your apartment complex, the levels are sort of like the floors of the apartment. And the sublevels are sort of like the, you could think of them as the number of apartments on that floor. So for example, the first floor, N equals 1, actually has only one apartment on that floor. Whereas N equals 2, the second level, the second floor actually has 2 apartments. And the third floor actually has 3 apartments, and the fourth floor actually has 4 apartments. And technically it would keep going, 5 apartments, 6 apartments, 7 apartments, but based on the number of elements that we know of in existence, in reality, 5th floor and up, really we only fill 4 apartments on those floors. In theory, it would actually have 5 apartments, 6 apartments, etc. The orbitals represent bedrooms. So these are the bedrooms in an apartment. And these apartments are really freaky. Somebody in my class said it was like the architect was on drugs. I thought that was pretty funny. So if we think of the apartment complex kind of looking like this. And so this is our first floor, N equals 1. And it turns out that on that first floor, there's only a 1-bedroom apartment. We call it an S apartment. So the S apartment has 1 bedroom. And in that bedroom, basically two people can live in that apartment. And I draw people like this. This is our electrons. They don't like to be next to each other. So when I draw them, you draw them with 1 arrow up, 1 arrow down, sort of like they don't want to sleep side by side in the bed. They want to be sort of flipped. All right, second floor. Now we're on N equals 2. It has apartment 2S. In other words, the apartment that's on the second floor, that's a 1-bedroom. And it also has another kind of apartment. We're going to call it a P apartment, and it has 3 bedrooms. On the third floor, 3S. Now this does not mean 3 S's. It means it is the S apartment on the third floor. So this is our 1-bedroom apartment on the third floor. There's a P. So there's a 3-bedroom apartment on the third floor. And there's also one called F, and it's a 5-bedroom apartment on the third floor. On our fourth floor, we have a 1-bedroom apartment. We're going to call this 5S. On, oh wait a minute, fourth floor, make that 4S. 4P, a 3-bedroom apartment. 4D, which is a 5-bedroom apartment, and 5F, which is a 7-bedroom apartment. And technically, when you get to the other floors, you actually don't go beyond the 7-bedroom apartment. So if we think of our 5th floor, it has a 5S, a 5P, a 5D, and a 5F. And the 6th floor, the same thing. So this is sort of the setup of our apartments. Each bedroom, remember, can only hold 2 people. So again, if we think about this, we could say then on the first floor, the total number of people that can live on the first floor, well, there's only an S apartment, so the maximum number of people that can live on the first floor would be 2 people. On our second floor, we know that we have apartment 2S and we have apartment 2P, and a P is a 3-bedroom. So 2S can hold 2 people, and then 2P can actually hold 2, 4, 6 people, 3 bedrooms. So the total number of people that could live on the second floor, 2, 4, 6, 8. 8 people can live on the second floor. On the third floor, remember, we have a 3S, which can hold 2 people, a 3P, which we said can hold 6, and a 3D, which was 5 bedrooms and therefore can hold 10. And that gives us a total of 18 people that can live on the third floor. And it just keeps going beyond that. SPDF, SPDF, etc. So this represents sort of how the electrons are going to fill an atom. So let's relate this to this right here. This is something you'd probably learn in AP chemistry, not in our honors class. This is actually showing the solutions to the actual equation. It literally has numerical solutions that then we have assigned the S, P, D, and all that sort of stuff. But I'm not going to go into that. So these are our energy levels. These are our floors. So we have our first floor, our second floor, our third floor, etc. Now, I'm not going to go beyond third floor right now, but notice our first floor, if you remember, only had a 1-bedroom apartment, an S. So let's say this is the apartment building for hydrogen. So hydrogen lives in a particular apartment building. It only has 1 electron. Where's that electron going to live? It's going to live in apartment 1S. So we would draw that as, this would be basically what we would call the orbital diagram for hydrogen. Another way we could write that, a shorthand way of writing that, is we could write 1S1. That means that there's an electron on the first floor, apartment S, and there's 1 electron living there. Now, this is our second element on the periodic table. What would the apartment building for helium look like? Well, helium has 2 electrons. So the orbital diagram for helium would look like this. On floor 1S, there's 2 bedrooms in that apartment. That's it. Our electron configuration for helium, our other way of writing this without drawing the electrons, is that it would be basically 1S2. That on the first floor, in the S apartment, there's 2 electrons. And if we went on, let's say that we go down here to our third floor. This is sodium here. Sodium's number 11. So if we were going to fill out, where do all the electrons live in sodium? Well, the first thing that would have filled in sodium would have been our first floor. So the first 2 electrons of sodium would be found in the 1-bedroom apartment on the first floor. On the second floor, we have a 1-bedroom apartment. That's going to fill first. And then we have a 3-bedroom apartment. That's going to fill second. So we've got 2, 4, 5, 6, 7, 8, 9, 10. We're now up to 10. We still have 1 more electron. Where's that electron going to live? It's going to live on the third floor in the S apartment. So our electron, our orbital diagram for sodium would look like this. This is showing us the addresses of all the electrons in the sodium apartment. The other way of writing this, the shorter way of writing this, is to write it as an electron configuration instead, where we would basically just write out, so in 1S we have 2 electrons. In 2S, we have 2 electrons. In 2P, we have 6 electrons. And in 3S, we have 1 electron. And so this is showing us the locations of the electrons in our building. Okay, so this is sort of repetitive, but this is just saying, so that was what we call our energy shell, our energy level. We called it the floor of the apartment. So that's the main level. Here's a diagram of it, n equals 1, n equals 2. Remember, we don't know the exact locations, we know the general area. And you'll notice that the floors, as you go up, are further and further away from the nucleus. You can actually numerically calculate the maximum number of electrons that can live on a particular floor. This is our formula, 2n squared. Okay, 2n squared is sort of a shortcut formula, but I'll show you, we already know this because we just worked it out. So for example, on the second floor, we said that on the second floor there was a 1-bedroom apartment, the 2S, and then there was a 2P apartment as well, which is a 3-bedroom apartment. So the maximum number of electrons that could fit would be 2, 4, 6, 8. 8 electrons can live on the second floor. If we work it out using 2n squared, 2 squared is 4, times 2 is 8. So this is just a shortcut way. Now somebody may say, well, what happens when you get to the 5th floor? Because technically, 5 times 5 is 25 times 2, 50 electrons should be found on the 5th floor. And that, in theory, is true. Yes, that's how many electrons could live on the 5th floor. However, what we're going to discover is sometimes it takes less energy to fill the bedrooms and the floors out of order. And so in reality, no, we never actually have 50 electrons on the 5th floor. And so I'll show you why in a second. Okay, so principal quantum number n. N is 1 through 7. This is the reason why it's only 1 through 7 is because, again, that basically takes care of all the elements that we know of today. In reality, could there be more? Yes. If we had more elements, they would have to have electrons and addresses beyond that. Then we have our sublevels and our orbitals. So our sublevels were basically the apartment building, and the orbitals were the number of bedrooms in the apartment. So for example, one of the sublevels is S. S happens to be sphere-shaped. Oh, this is just the orbital, which is the location of finding the electron. Again, the electrons don't want to be next to each other, so when we draw them, we kind of draw them like this. The idea is that they would be spinning in opposite directions, one clockwise, one counterclockwise. So here's our shapes. So think of our one-bedroom apartment has a spherical shape. So that's called the S apartment. It has one spherical bedroom. It's kind of weird looking if you were to imagine it. The second shape, the P apartment, here we go. Our P apartment is dumbbell shaped. It actually has 3 orientations on the axis. I'm not going to go through that right now, but bottom line is, think of it as the P apartment is the 3-bedroom, has 3 orbitals. The orbitals are like the bedrooms, and therefore P can hold 6 electrons. D, they say, has a more complex shape. It has to do with sort of a cloverleaf shape. Bottom line is, when it's all said and done, it's a 5-bedroom apartment, so it can hold 10 electrons. And then F, in most books, they just say, hey, it's complicated. It's a 7-bedroom apartment, so it can hold 14 electrons. So these are basically the types of apartments. There's the 1-bedroom apartment, the 3-bedroom, the 5-bedroom, the 7-bedroom. All right. Here's just some diagrams. As we get on the different floors, the 1S, 1-bedroom apartment is actually smaller than the 2S, which is smaller than the 3S. We're getting further away from the nucleus. This is showing a 2P. This is showing a 3B. Just some diagrams. Going to move past that. We just talked about this, 2n squared. And this is sort of a summary. So on the first floor, there's only one apartment. It's a 1S. It's a 1-bedroom apartment. On the second floor, there's 2 apartments. It's a 1-bedroom, which is called the 2S, and a 3-bedroom, the 2P. On the third floor, there's 3 apartments. There's a 1-bedroom, a 3-bedroom, and a 5-bedroom. And then on the fourth floor, there's 4 apartments, a 1-bedroom, a 3-bedroom, a 5-bedroom, and a 7-bedroom. And we just go from there. All right. There's 3 rules that basically determine where are these electrons going to live. The Aufbau principle basically says they're always going to occupy the lowest level first. It would be nice if that meant that they occupied the floors in order. It doesn't necessarily mean that, but it does mean energy-wise. Think of it this way. It takes a lot more energy to run the air conditioning in a 5-bedroom apartment or a 3-bedroom apartment than it does for a 1-bedroom apartment. So sometimes the 1-bedroom apartment on the next floor will fill before the 5-bedroom or 3-bedroom apartment on a previous floor. It just takes less energy, and that's just what the atoms do. The second one says that the Pauli exclusion rule basically says that the only 2 electrons can fit in a bedroom. They spin in opposite ways. And the last rule basically says that Hund's rule basically says that, let's say that you have a 3-bedroom apartment and you have exactly 3 electrons. Let's say we're on level 3P. If they don't have to share a bedroom, they're not going to share a bedroom. So if you had exactly 3 electrons on 3P, the proper way to write them would be like this, not this. This would be incorrect because they don't like to share a bedroom if they don't have to. They're going to spread out. So that's what our third rule says. All right, so an orbital diagram is just a way of drawing this out. Here's some really quick diagrams showing like the sodium apartment. In the sodium apartment, here we are. We have our 1-bedroom filled on the first floor, our 1-bedroom filled on the second floor, and then our 3-bedroom filled on the second floor, and now our third floor, we have 1 electron left over, a 1-bedroom with 1 more electron. All right, And this is the electron configuration, which looks a little bit different. So that's the end of part one. I'm going to give you a part